Okay, so continuing with parabolas, another way to find x-intercepts of a parabola is factoring. So here's a parabola, y equals, remember f of x equals y, x squared minus 4x minus 21. We want to find the x-intercepts, so we set y equal to 0. That gives me the equation 0 equals x squared minus 4x minus 21. And the goal is to find two numbers when we're factoring, two numbers that multiply to give minus 21, add to give minus 4. So multiply to give this number, add to give that number. So factors of 21 are 21 and 1 and 7 and 3. And 7 and 3, if you subtract one from the other, you get minus 4. So minus 7 times 3 equals minus 21. Minus 7 plus 3 equals minus 4. And so those are the two numbers we're looking for. So once we know those numbers, we can rewrite this as x minus 7 times x plus 3 equals 0. So minus 7 times 3 is minus 21, minus 7x plus 3x, that's my minus 4. So if we have two things multiplied together to give me 0, either one of the two has to be 0. So either x minus 7 equals 0 or x plus 3 equals 0. And this tells me that x equals 7, that's one x-intercept. That's x equals minus 3 is the other x-intercept. So if we think about what our parabola would look like, it goes through x equals 7, and it goes through minus 3, and it opens upwards. So it looks something like that. Now, where's the vertex? The vertex is down here. Where should the vertex be? Well, the axis of symmetry goes through the vertex, so it should be the same distance to the x-intercepts on either side. So we know that the x-coordinate of the vertex is minus b over 2a. And in this case, that's 4, because it's a minus 4 over 2, which is 2. So this is 2, and 2 plus 5 equals 7. 2 minus 5, oh, that's badly written. 2 minus 5 is minus 3. So the x-coordinate of the vertex is 2, and the two x-intercepts are 5 units to the left and right of it. So roots, a root is a solution to f of x equals 0. Right? And if we know a root, well, roots correspond to factors. So if we look at this, right, the root was x equals 7. What's the factor that the root came from? Well, that's x minus 7. We had a root that's x equals minus 3, right? And that came from the factor x plus 3. So if you know a root, you can figure out the corresponding factor. If you know the factor, you can figure out the corresponding root. But not all roots are x-intercepts. Sometimes our roots are actually complex. So remember that a root is actually a solution to an equation. It's an algebraic thing. A x-intercept is a point on a graph. It's more of a geometric thing. So x squared plus 4x plus 5 So if we go way back up to example 6, that was the place where we found out that our quadratic formula, x squared plus 4x plus 5, was complex, the solutions were complex, and that corresponded to not having any x-intercepts at all. So the complex roots don't correspond to x-intercepts. But we can still factor with that, because if I have the root is x equals 2 plus I, and the other root is x equals 2 minus I, then the factors are x minus the quantity 2 plus I, and x minus the quantity 2 minus I. So x minus the root gives you a factor. So we can actually factor this thing. It becomes this, right? And if you multiply that out, if you multiply out the thing with the complex numbers, you'll actually get the x squared plus 4x plus 5. So every time you have a root, you have a factor. Every time you have a factor, you have a root. Some roots are x-intercepts, right? Complex roots are not. So we can actually factor this, right? If you look at this, you'd think, okay, to factor this, I would need two numbers that multiply to give me 7 and add to give me minus 3. So 7 would be 7 and 1, and that doesn't give me minus 3 anyway. But we can solve this. Replace the y with 0, because we're looking for x-intercepts essentially. X squared minus 3x minus 7, and that gives me x equals 3 plus or minus b squared, which is 9 minus 4ac. But minus 4 times minus 7 is plus 28 all over 2a. So x equals 3 halves plus or minus the square root of 37 over 2. And so what do we have? We have two roots. X equals 3 halves plus square root of 37 over 2. And x equals 3 halves minus square root of 37 over 2. And what are the factors that go with those roots? Well, x minus a root is one factor, and x minus the other root is the other factor. So we have now factored x squared minus 3x minus 7. It's x minus 3 halves plus square root of 37 over 2 times x minus 3 halves minus square root of 37 over 2. And there's our factorization. So all quadratic formulas can be factored. All quadratic equations can be factored. Sometimes the factorization is not particularly pretty. Sometimes it involves complex numbers. If you can do this sort of thing to get it to work out, that's sort of simplest. But you can always use a quadratic formula to find factors. So quadratic inequalities. This is when we have a quadratic formula greater than 0 or greater than or equal to 0, less than or equal to 0, less than 0. And we want to know what x's make the inequality true. And we can do this in two different ways. One is graphing, and the other is finding roots. So we want to graph this thing. First thing to do is rewrite so that it's x squared plus 3x minus 4 is less than 0. Because we want to have a 0 on the right side. And so now this is a quadratic. This one we can actually factor. With integers, right? Minus 4 and plus 4 and minus 1. Oops. Don't need that, so less than 0. That's just a scribble. Great, so there's our factorization. So this is, if we graph y equals x squared plus 3x minus 4, what do we get? We get a graph that's got an x-intercept at minus 4. That comes from here. That's the root that comes from that one. And an x-intercept at 1. That comes from this one. And the y-intercept is actually also at minus 4, because if you plug in 0, you get minus 4. So our y-intercept is down here. Where's our vertex going to be? It's halfway between these two, so that's going to be at 1.5. And so we have a graph that looks like that. That's our graph for a parabola. That's supposed to go through one, but sometimes a tablet isn't so useful. Great. So what are we interested in? Y is this thing, right? That's what we're calling that. And we're interested in when y, the y coordinate here, is actually positive. So y is greater than 0 on this part, on this interval, up to 4, and y up to -4, and y is greater than 0 in here. In between, y is less than 0. So this is less than 0 when you graph it and it's below the x-axis. So the solution is the interval from -4 to 1, or -4 less than x less than 1. That's our solution. So when we think about a function being greater than 0, that means we're talking about above the x-axis. A function less than 0 is below the y-axis. So we can graph and look at it. We can do a sort of similar thing, though, by looking at, I'm going to actually delete that because I don't have GeoGebra up and running at the moment. X squared minus 3 greater than x using the quadratic formula and test points. So again, first thing to do is make this have a 0 on one side, okay? And then this is a quadratic, and we can think about if we graph that quadratic, when is it positive, when is it negative? So what we're interested in is solve x squared minus x minus 3 equals 0. And that's a little bit tricky because it doesn't factor nicely, but we can always use the quadratic formula, 1 plus or minus the square root of b squared, which is 1, minus 4ac, which is plus 12, all over 2, because minus 4ac is minus 4 times minus 3, plus 12. So x equals 1/2 plus or minus square root of 13 over 2. So those are our roots. So if I think about the x-axis, I've got 1/2 minus square root of 13 over 2, and I've got 1/2 plus square root of 13 over 2. And what we know about parabolas is that these are the x-intercepts, right? And so a parabola can only change sign if it actually goes through an x-intercept, right? You can only change from positive to negative when you go through an x-intercept. You can only change from negative up to positive if you go through an x-intercept. So in between these x-intercepts and outside of these x-intercepts, the function doesn't change sign. And what that means is I can pick a point in here, we'll call it 0, and we'll call this a test point that's in between them. And we can see when we plug in 0 into this, do we get something positive or negative? Not quite sure why that happened. So x equals 0. We plug that into the left-hand side here, and we get 0 minus 3. That's less than 0. So the graph is less than 0 in between here and here, right? If we take a number bigger than 1/2 plus square root of 13 over 2, so something like, I don't know, 10, we get 100 minus 10 minus 3, that's definitely positive. So out here, positive, that means greater than 0. We take minus 10 out here and use that as a test point. Plug it into this, that gives us minus 10 squared, which is 100, plus 10, because minus 10, minus 3, and that's definitely positive, greater than 0. Great. So we're looking for places where this function is positive, and that's this interval up to here, and this interval all the way out. So it's minus infinity up to this x-intercept, which is 1/2 minus square root of 13 over 2, including it because it's a greater than or equal, union 1/2 plus square root of 13 over 2, comma infinity. And if you graph the parabola, actually, if you think of this as my x-axis, if you graph the parabola, it would look like that. Down here, it's negative. Out here, it's positive. Out here, it's positive. It opens up, so it's positive on the sides. Okay, so quadratic word problems. Maximum, minimum of a quadratic function. Remember, when you're asking for maximum, minimum of a quadratic function, that means what they're asking for is what's the vertex of the parabola. So what is two numbers that add up to 10? Product as big as possible. So we'll take our two numbers. We need variables for these things. And you can always tell what things need to be variables because they tell you to find them, right? Find two numbers. Well, what are the two numbers? We don't know. They're unknown. So we give them letters. We'll call them x and y. What do we know about these two numbers? They add up to 10. So x plus y equals 10. And we want the product to be as big as possible. So what we're looking for is maximizing xy. And we'll call that a function. We'll call it p. And we call it p for product. So we want to maximize p. So my function then is p equals x times 10 minus x. Where did the 10 minus x come from? Well, that's from this. 10 minus x is equal to y. So I can just replace the y here with the 10 minus x. And that's minus x squared plus 10x. So there's a parabola. And what we want to know is what's the vertex of this? And we know what the vertex is. H, which is the x coordinate of the vertex, is minus 10 over 2, minus b over 2a, so times minus 1, because a is equal to minus 1. And this is just a little blurb there. So h equals 5. That's my x coordinate of the vertex. And k is, well, we plug 5 back into this, and we get minus 25 plus 50 equals 25. So what is the vertex telling us here? Our product has roots 10 and 0, right? From this gives me a root of 0, this gives me a root of 10, and my vertex is at 5. This is x, and this is p, and what are we finding out? That the biggest value of p is 25, and it occurs when x equals 5. So and what are x and y? They're both 5. And once we know x, we can plug that in here to get y. Okay, so it's a problem that turns into a parabola, and you're trying to find the vertex of the parabola. This is going to be along the same lines. We've got riding stables. They've got a bunch of registrations for the next horse show, and they need additional paddock space to put the horses. So they can rent 1,200 feet of temporary chain link fencing, and the plan is to form 2 paddocks with 1 shared fence running down the middle. What's the maximum area that the stables can obtain, and what are the dimensions of each of the 2 paddocks? So what are we looking for? Max area and dimensions, right? Okay. A little hard to get started, but the idea is to just draw a picture for something like this if you're not sure what to do. And it doesn't say specifically that it's going to be rectangle, but we'll form 2 rectangular paddocks like that. And there's a shared fence between the 2 of them running down the middle somewhere. It turns out it doesn't really matter where you put that thing. So what's the maximum area that the stables can obtain, and what are the dimensions of each of the 2 paddocks? Well, what they've got is we want to know what's the area of this big rectangle. So we'll call that side x, and we can call this side y. So we want to maximize area is equal to x times y. We want to maximize the area. Now, the problem is, of course, is that x and y, that's not a parabola yet. But they give us a nice piece of information. They have 1,200 feet of fencing. Right? X is how long this is, and you're going to need 3 of those to build your paddocks. So your 1,200 feet of fencing has to be broken up into 3 sort of vertical sections and 2 horizontal sections. And so now we have a relationship between x's and y's, and so we can solve this for y. That gives me 1,200 minus 3x equals 2y, or 600 minus 3 halves x equals y. Take this and plug it in to here. And what do we have? We have a parabola. What are we trying to do? We're looking for the maximum area. Our area is the output of a parabola. If you know the vertical height now, we can figure out what the area is. And so we can figure out what's the vertex. And that'll give us our x. Once we know our x, we can find our y and our area as well. So the vertex, again, is minus b over 2a, and in this case, b is 600, and 2a is 2 times minus 3 halves. So minus signs cancel out. We've got a 600. 2 times 3 halves is 3, and so x is 200. So this should be 200 feet. What's y then? Y we get from this equation, once we know x, y equals 600 minus 3 halves times 200. We can cancel that out and be left with a 100 there. So we have 600 minus 300, and that equals 300. So x is 200, y is 300. Maximum area is 200 times 300, which is 6 followed by 4 zeros. 60,000 square feet total. And this is, well, I guess we'd make this x by 150, make this 150. This is 200. This is 200, 150, 150. So area is height times width. They give us a restriction about how long the sides can be. And we can solve that for y. We get a parabola and we can solve it. So this is along the same lines, right? A car rental agency can rent every one of its 200 cars at $30 per day. For every dollar increase in rate, 5 fewer cars are rented. What's the rental amount that will maximize the agency's daily revenue? Right? We want a vertex. And what's the maximum daily revenue? So revenue is price times quantity. Right? What you can charge for something times how many you can sell of them. So this is the number of cars they rent, and this is the price. So we'll use letters R equals P times C. P is price, C is number of cars rented. So what do they tell us about this? Every dollar increase in rate they rent 5 fewer cars. So if we plot price versus cars, P versus C, what they're telling us is that when the price is 30, they can rent 200 cars. If they increase the price to 31, they will sell 195, rent 195 cars. So there's the price demand curve. How does the demand for your product depend on what price you charge? And the higher the price, fewer people buy it. So this is a line. The slope is, well, we're going down 5 units and to the right 1 unit. So the slope is -5 cars per dollar, right? Every dollar you increase the rate, so every dollar you go to the right, you lose 5 cars. Number of cars you got goes down by 5. So the slope is -5 cars per dollar. And so what's the equation of the line? Cars minus 200 equals -5 times price minus 30. And if you solve that for the number of cars, get that is -5 times the price plus 350. And so solve that for the number of cars. So what's my revenue then? It's price times cars, and that's price times -5p plus 350. So revenue is -5p squared plus 350p. It's a parabola. So what's the vertex of this parabola? Vertex. The x-coordinate is h equals -b over 2a, which is -350 over 2 times -5. So that's 35. What's the actual revenue? Right, k. That's the y-coordinate of the vertex. Well, you take -5 times 35 squared plus 350 times 35. We take our 35 and we plug it into the revenue function. This is an x-coordinate. To get the y-coordinate, you plug that in there. So k equals 2625. So we think about what a revenue function looks like. It's got one root at 0. So this is price versus revenue. You get one root at 0, and then if you set this equal to 0 and solve, you get 70. So if you set the price to 0, you don't have any revenue because you're giving away all your cars. They can go rent them and they won't pay you anything. If you set your price for 70, it's so expensive nobody rents your cars. Somewhere in between is your maximum revenue, and that happens at the peak of this vertex. And that happens when you charge $35, and then you have a maximum revenue of $26.25. How many cars do you rent out? Well, if your price is 35, you can plug that into here to figure out how many cars that you rent out. You actually rent 175 cars. Okay, so when you ask for a maximum, it means that you're looking for the vertex of a parabola. So, and then back here is the highlights of what we've done. And so that's parabolas.